So this is the final assembly of my project. As you can see, this is the EMG sensor that's detecting the signal from the biceps. I'm a student here in the UK and I'm currently doing my A-levels. For a project in my school, I decided to make something. I am really fond of physics and I really love doing it, so I knew that my project had to involve physics. Also during this time, I was rewatching the Iron Man movies, and so I had almost an epiphany on maybe I could build an arm exoskeleton that could maybe help people with paralysis regain movement in their arms. As we all know, to go from a concept to a product can be hard, and so when I looked online to find any videos or research papers, I struggled to find any that were actually helpful. So I decided to make this video for two reasons. One, obviously, I want to present my work to all of you. But secondly, I want to make things easier for people who want to build something like my arm exoskeleton or something even bigger. So this can act as a starter video to help you get started. This arm exoskeleton is designed to increase power while reducing muscle fatigue in your arm. It does this using an EMG sensor. An EMG sensor senses signals that your muscle makes every time you move it. Using this signal, after it reaches a certain threshold, I code it to turn my motor. And then I integrated my motor into my arm exoskeleton so that when the motor turns, the arm exoskeleton turns, therefore increasing the power of your arm. I broke down making this arm exoskeleton into three main categories: actually building the arm, the circuit board, and the coding. The components I used for my circuit board is an Arduino Uno, two EMG sensors, one for the biceps and one for the triceps, wires obviously, a capacitor, and an A4998 motor driver, and a NEMA 17 motor. So I integrated this EMG sensor into the circuit board by adding it to these variable analog in pins here. You can attach the EMG sensor onto your biceps or triceps using these electrode pads. For the actual connection to the motor, you have to buy a motor driver for the correct motor. So for my motor, I had to buy the A4998 stepper motor driver. This is a 16 volt capacitor and a 10 ohms resistor and a button to act as an emergency stop button. So to actually make the arm exoskeleton, I attached a NEMA 17 motor to two wooden planks and attached it to an aluminium plate. To make the joint, I attached the two aluminium plates together with a big gear, as you can see over here. I then attached a smaller gear to the second aluminium plate. So when the NEMA 17 motor shaft turns, the big gear turns, which makes the small gear turn, which should therefore account for the actual arm to turn. I then attached it to another person's arm using these straps and adding Velcro to them. I then added wooden planks onto the motor to make it easily attached to the arm. I hot glued everything to make everything sturdy. For the final part, let's look at the code. For the code, I started out by establishing the pin connections. The direction pin is 2, the stepper pin is 3, the stepper enable pin is 4, the sleep pin is 5, and defined each one of the variables on the motor driver with 10, 11, and 12 pin numbers. I defined the EMG pins as the bicep pin as A5 and the tricep pin as A0. Then I established the stepper settings, which I used to decide how fast and how much my motor would turn. So the motor steps is 200 and the micro steps is 16. And I set the RPM as 100. Then, to make my EMG sensor signal cleaner, I programmed a software that averages out the signal. You can see this from line 30 to line 46. Then I worked on the timings, where the previous micromotor is equal to 0 and the motor interval is equal to 100. I then set the motor state, which you can see from line 53 to line 79. And then I worked on the motor control logic. So for my motor control logic, I said that if the biceps average is bigger than the biceps threshold, and the biceps average is greater than the triceps average, the motor would be on and the direction would be clockwise. Similarly, if the triceps average is bigger than the biceps average, then the triceps would turn. then the motor would turn anti-clockwise. I've put all my code and everything that I've used, the Arduino starter kit, the motor driver, in the description, so you can just get started yourself. So this is the final assembly of my project. As you can see, this is the EMG sensor that's detecting the signal from the biceps. The signal gets sent through the wires to the Arduino, which sends it to the code, so I can see it over here. Once the signal reaches a certain threshold, the signal gets sent back to the Arduino, which gets sent through the motor driver all the way back to the motor, which in turn turns the motor, which turns the arm-exoskeleton. Can you flex? So if I had a more powerful EMG sensor and a stronger motor, I would be able to recreate this, but instead of the test subject having to flex so much before the motor turns, the motor would turn really smoothly. Therefore, the arm exoskeleton would be able to smoothly assist the person in everyday life. With better quality materials and a stronger motor, I think my project would have turned out a lot more sophisticated. But as you can see, this is proof of concept. Thank you so much for watching. If you have any questions, please do comment on the video.